Hello. Welcome to the second half of our semester. This is EGR210, and we have a very interesting way that we're going to be attempting to teach this class from now on. I've been providing lectures, and I've been providing this in a very group-oriented style learning. This is all new to me too. I ask you to bear with me. This is not normal for anyone. I have done some online teaching before. I can't say I enjoy it. I can say that I am very uncomfortable with doing a lecture where I can no longer see my students' faces. I really enjoy that interaction between people, but we haven't had that chance. So please understand that we're all getting through this together. I want to do what I can to give you this material, prepare you for engineering education in the future, prepare you for understanding how to do engineering projects and what engineering really is. That's kind of my goal with this class. So we're going to be attempting to do that remotely. There are a lot of engineers all over the world right now that are doing remote work. Not all engineering requires being on site. One of the nice things about being an engineer is that most of the stuff we do can be done on a computer and can be done from anywhere. A lot of design and analysis and thought process. We've talked about group work, teamwork. We've talked about writing proposals. We've talked about doing research. We've talked about cost estimates. We've talked about a lot of different concepts, none of which require us to be in person. A lot of engineering is just analytical work. It's design work. It's coming up with solutions. It's being able to work on your feet, being able to do problem solving. We're now at a place where we have to do some problem solving online. So we just have to move forward. So what I thought I would do for this first video is give you an introduction to what I want to do for the rest of class. Now I was hoping to give this video via live stream. I was not able to make that happen. I tried using my webcam on my computer and it was such low quality and the audio was cutting out, and I'm just sitting there going, let's not do this. I don't want to give you a really poor quality video and just blame the fact that the internet sucks and dang it, Bill Gates, why you gotta make them computers, and I want tech that carries me around everywhere. I'm not gonna play that game. I wanted to give you a real quality video, and I want to give you continued quality video. I'm looking for ways to make that work. For right now, I may just have to buy a subpar webcam and try not using my computer webcam. We'll see what happens. We're not going to be discussing Revit at all. Revit is gone. I was hoping to cover that. I would prefer that we spend more time on SolidWorks, and Revit is important for civil engineers, particularly anybody who's going into structural engineering. Revit is very valuable. However, it is not used really outside of civil engineering at all. AutoCAD is used in many places, and fundamentals of AutoCAD are used in electrical engineering, mechanical engineering, environmental engineering. I know of people in all industries who still use AutoCAD and use them regularly. Now, they tend to be smaller firms, but having an understanding of AutoCAD generally gives you an ability to create professional level drawings and have them look really nice. So I think AutoCAD is very important. That's why we started the class with it. Now, SolidWorks is important for many reasons. SolidWorks is used in the engineering world, mechanical, civil, electrical, and environmental. All of them use SolidWorks can use SolidWorks in some aspect. Some people use programs that are a lot like SolidWorks, and the functionality that SolidWorks provides, I think, is beneficial. Whereas AutoCAD is really good for 2D modeling, SolidWorks is much better at 3D modeling. And having 3D modeling capabilities, it allows you to do 3D printing, which is something we're not going to be able to do as a part of this class, because thank you, COVID. But it does allow you to do things like 3D printing. It allows you to do things like visual modeling, where now you take a 3D print and you render it and put it in an environment. It lets you see how it looks. A lot of engineers will have to come up with their own custom solutions. They need custom tools. They need something custom made. They may need to have a machine shop build something for them. I need you to make this part. I need you to make this filter. I need you to make this. Having the 3D modeling capabilities and the kind of things that we're going to be discussing in SolidWorks will give you the ability to say, well, I need X made. Here's how to do it. So we will be doing SolidWorks. We'll do it a lot similar to how we did the AutoCAD learning, where there will be videos and there will be quizzes associated with that. And I'm going to be posting those. With us not doing Revit, Project 2 is gone. We're quitting on Project 2, which is disappointing to me because that was one I was very excited about, but we have to be flexible in this world, and we have to be flexible with these solutions. So no more of that. We're now looking at having one project that will be a kind of a cumulative project. I'm going to have you do it by yourselves, which I guess violates all of our ideologies for this class, but it is going to reduce your need to communicate with others, and it should make this a lot more streamlined. My goal is to make this less painful for each individual and more instructive. And some of that means I do have to relax on my expectations. I'm not expecting all of you to download SolidWorks and use it. However, if you don't download SolidWorks and use it, I will be expecting you to hand draw something that looks like it. And that's not fun. It isn't fun at all. So again, I have to lower my expectations. I just need you to show me that you can provide a professional display. And if it means you have to sketch it out on paper and take a picture of it, so be it. I would prefer a SolidWorks drawing, but if you can't get SolidWorks because you have a Mac or your computer can't handle it, then that's all we can do. Let's do a quick review. Next week we're going to be discussing House of Quality, and House of Quality is a decision matrix. So we're going to be discussing a little bit of decision matrices today. Decision matrices are in engineering, even in math, engineering, science, it is a great way to take a qualitative problem and turn it into a quantitative problem. It allows you to perform analytics, it allows you to perform comparisons and make decisions where you have hard numbers dictating what decision you should make. It's basically like saying, if you were to try to live your life where you made the most reasonable decisions possible, you could use decision matrices to make absolutely every single one of your decisions, no matter how qualitative or quantitative. So we're going to be discussing that. Let's do a review of the course first. So things that we've talked about so far in this class have been problem solving. The important part about problem solving is that when you go to do problem solving, which engineering is very much problem solving, you have to have a foundational knowledge, but you also have to be willing to iterate. You have to have plans in place for assessing whether or not your solution is valid, whether or not it satisfies this solutions and the conditions that you provide, and so that you can sit back and say, well, is the problem solved? As a part of the problem-solving process, we discussed the engineering design process. Now, the engineering design process, the way that I use it in class, is it is a problem framing. Here, you identify the measures of quality and the oh, this is the functional requirements, this is the constraints on the system. If you need something that has to be smaller than this size, that is important to the problem. In the problem framing, you are understanding what the problem is. In the ideation phase, you are developing different solutions that could possibly solve the problem. You are understanding, you are reaching out and discovering a broad variety of problems. Okay, after the ideation phase, here's where we go into realization. This is where we pick one solution, usually based off of a decision matrix, and we move into actually developing something, building, testing, something of the sort. And finally, ends with analysis. This is where we say, did it solve the problem? Did it solve it well enough? Did it solve it better than its competitors? Did it solve it better than previous iterations? What can we do better in future iterations? Because what is this item lacking that we need to do better? Maybe it's something as simple as, well, we need to replace this with better connections. Maybe we just need to use a different material, a more lightweight material. But it may involve complete redesign of a system. So all four of these are very important to the engineering design process and fall into really what problem solving is. We talked about teamwork, the importance of establishing roles as team members to identify really what is it that you're contributing to a team. And we talked about proposals. Now what you're going to be doing for your final project is you are going to be working on a proposal individually. I'll give you the format for it, I'll give you a template for it, I'll make it nice. But the purpose of a proposal is to allocate funds. Now that includes time, it includes human resources, and it includes material resources. We talked about how proposals are really a good way of getting your foot in the door so that whoever you're working for, a government agency, a corporate entity, or even a person, is willing to allocate what is needed for you to perform this work. We'll be talking a little bit more about proposals as I introduce the project, which I'm hoping to do next week. And then we also talked not just about proposals, we talked about understanding your job titles and your resources. So here, I spelled that right. So here, what kind of manufacturing capabilities do you have? What kind of individuals do you have as a part of your team? What kind of expertise do they have? What do you need to have? Do you have to outsource some development of a product or some service? Do you need to contact somebody who's going to tell you something you need to know in order for you to complete this project? There are entire careers where people themselves do not know, they're not experts in a field. They just know how to contact people and get them to tell them what they know. That's it. You pay them for their service, and you get paid for it because you combined all of these resources into one to provide one solid package. That's viable. You don't have to know absolutely everything, but how much are you going to be providing unique to you, and how much is somebody else going to be providing? That all plays into a proposal. And really, a proposal falls into everything. It's a culmination of doing all of this together. So this is just what we've talked about so far this semester. Now let's talk about, of course I would get a phone call right in the middle of a video. 1 second. Oh, it's not anybody I need to really talk to, so I'm just gonna, oh, it went away. This is an introvert's dream. I can ignore people and pretend I'm sick or not present. Introvert. I've played a lot of Animal Crossing lately. It's an introvert's dream also. Anyways, so we're going to talk about decision matrices right now. As I discussed, this is a quantitative decision-making process. The purpose of having a quantitative decision-making tool is that it allows us to turn everything into a math problem. In math, there is only one right solution to a problem. You're given a problem, you have one derived solution. That's it, nothing more. Okay? So to get a quantitative decision-making tool means we're going to put together a decision matrix and we're going to say we want this to give us a finite definitive answer. We have one answer this is giving us. Okay? A decision matrix is nothing more than, let's say we have option 1. Well, maybe we are considering purchasing distilled water because we need distilled water for our apocalypse bunker. Okay? And we'll say option 1 is make your own water. Okay, we'll say option 2 is buy in bulk, buy bottled water in bulk. That's bottled. Okay, maybe option 3 is buy one of those 5-gallon jugs. And maybe option 4 is drink rainwater. Okay, now how are we going to decide between which one of these we're going to do for our apocalypse bunker? Well, we need some way to identify how to compare them. Well, in our problem framing, which we talked about previously, we have come up with comparative methods. That's our measures of quality. Measures of quality are intended to be comparative measures by which we can evaluate each other. So let's say I got my 4 options. I'm going to throw up, okay, let's see. I want safety is one of my measures of quality. How safe is it? On a scale of 1 to 10, how many different bacteria are going to be present in that water that will murder me? That kind of a thing. So we'll say safety is number 1. We'll say water purity is number 2. That you can come up with some way of measuring water purity. So we got safety, we got purity, access. How easy is it going to be for us to keep this, store it, access it, use it? Okay. How hard is it going to be to get? That's going to be another aspect of, it may be you may have the best water in the world, but if it's impossible to access, great. And finally, cost of initiation. Each one of these is going to require us to spend some money before the apocalypse to obtain water, and then afterwards, that kind of a thing. So, make your own water, we give it a scale of 1 to 10. Maybe we give all of these a scale of 1 to 10. We can do that. You may have individual values that you can give. You can actually give water purity in parts per million if you really want to. And then maybe you can give down here, you can calculate a percentage score off of that, 0 to 100% on your water purity level. We can come up with whatever algorithm we want to analyze this data. We just need hard numbers to put into that we can use to develop math equations. So I'm just, for the sake of ease, I'm going to start by saying all of these are a scale 1 to 10. Okay, so we'll say making your own water is probably a 6. Purity of the water will probably also be a 6. You can probably get out most of the impurities. Access to that water, well, if you're making it yourself, then you're probably going to be able to find a water source somewhere to be able to make it yourself. This is probably a 10. That'll probably be the best access. Obtaining it, well, when the apocalypse happens, how easy is it to obtain? Well, once again, since you're making a water yourself, as long as you have water somewhere, it doesn't have to be clean, you can purify it yourself. Now, the problem is, when it comes to the cost of initiation, all of the filtration that's required, all of the different processes that are necessary for running water purification, this is going to be very expensive. Okay? Purchasing bottled water in bulk and purchasing the 5-gallon jugs, Both of these are probably going to be your safest option. And they probably both will have the highest purity. Now, access to these water depends. In today's world, with as crazy as supply gathering has been, you may be looking at a 4 for the 5-gallon jugs, and you may be looking at a 2 for the bottled water. Obtaining afterwards, it basically drops to a 1 because it's going to be almost impossible. People are going to be using those resources. Cost of an initiation, though, this one's probably going to be an 8. This will be a little bit cheaper. This will be a little bit cheaper overall. So, really, there's no reason to buy bottled water because it scores worse than the 5-gallon jugs and everything. We didn't include usage. Usage would be hardest for the 5-gallon jugs and easiest for the bottled water. But we could always expand our decision matrix to include that aspect. Drink rainwater. Well, it is not safe, particularly if there's nuclear fallout. So we'll put this as a 2, unless you really want to grow a 4th arm, in which case then why are we even looking at purified water? The purities, maybe more than that. I don't know. I'm gonna say it's a 1. Access to rainwater again is a 10. This is with the apocalypse. Hopefully, it won't prevent rain from happening. Obtaining post-apocalypse, this is again a 10. You just need a giant jug. Now, the cost of initiation for this is probably going to be an 8. You need some giant jugs. You need some rainwater collection systems. But you could probably spend less than $1,000 and do that. Whereas here, to have a running, maintaining system, you could spend $50,000 to come up with your own fresh water supply station. That is something that would be viable 20 to 50 years in the future. So, comparing these options now, what we can do is, since we have now numbers for all of these, we can say, what is your score? Well, what I'm going to do for this score is I'm just going to do a simple addition. Okay? This plus this plus this plus this plus this. The higher the score, the better the option. So this is 12, 22, 32, 33. Okay, 22, 31. 20, 24, 25, 35, 28. This is also 31. So, according to these metrics, the way that we've assessed them so far, these two are about as good of an option as each other. You can either drink bottled water or drink rainwater. So there's some nice benefits. Now, does this really tell the right story? Is buying 5-gallon jugs your best option? Well, maybe. It really depends on the conditions. If all of these have equal weight, then it depends on your conditions. Let's say you're independently wealthy. If you're independently wealthy, then your cost of initiation doesn't matter. You want to survive at all costs, and that matters way more than how much it's going to cost. Okay? But in that case, you're going to want to make sure that you have a solution where you can continue to obtain water. So this matters a lot, this matters less. And your safety is probably going to matter a lot too. Purity, if you can overlook a few floaties, great. But now we want these two to be our most important features, and we want the rest of them to be less important. Okay? How do we adjust our score to be a new math problem? Right now our score is just category A plus category B plus category C plus category D plus category E equals score. Okay, right now this is the math problem that we're using. But we could adjust this and we could say weight of A multiplied by the score of A plus the weight of B multiplied by the score of B plus the weight of C multiplied by the score of C, and so forth. We could do that and now have an additive score that is based on a weighting scale. So here, cost of initiation, depending on how wealthy you are, may be a weight of 0.5, 0.1. Whereas safety may be a weight of 10 or 4 or 5. You play with the weights until you get a solution that makes sense. And adjusting your math problem will give you different answers. But all of your answers as long as you can justify your weights, as long as you can put some justification into it. This is a math problem, and that's all it is. And your math is up to you. It's very qualitative in how you assign the weights, how you calculate the score, how you get values out of here. Even this is a qualitative process. What's the difference between a 10 and a 9 here? I don't know. Maybe I can't have a guarantee that my water is safe and pure. Well, maybe Ed down at the tackle shop has just been filling up bottled waters in his backyard with a water hose. You never know. So we may not be able to say 10 here, but I guessed 10. So this is all, it's a very qualitative process, but when we put it together, it comes up with a mathematical solution. And all of this depends on your engineering judgment. Well, what is engineering judgment? Engineering judgment is the ability to state qualitative things like this and say, here's what it is. In my opinion, based on my experience, based on my knowledge, based on my research. I think this is the most important. So a lot of this relies on previous knowledge. A lot of it relies on what you were able to do beforehand, but once you can put together like something like this, you can make a decision very easily. Here in this one, it's buy 5-gallon jugs. With the weighted scale, it's make your own water. Okay, if I'm a germaphobe and these two are the ones that matter most to me, and maybe cost doesn't matter, maybe I don't care as much about how I'm going to obtain it after the apocalypse because I'm assuming I'm going to be able to get water somewhere. Maybe if these are the two that matter most to me, then clearly these two are the best option. And either one of them works. So decision matrices allow you to take something like this, turn it into a math problem, and be able to use that math problem to come up with a definitive, comparable result where you can now compare the numbers, which one is the greatest, to come up with your best solution. Okay? And I just came up with an arbitrary A plus B plus C plus D way of evaluating this. You could come up with anything. It could be all of them multiplied by each other. What that means is you don't want to have any scores that are low. If we multiplied all of these together, this is what, 3,600? 3,600, this is 200, 200, 1,600. This is 100, 400, 4,000. Okay, so this is a better solution so far. And this is 200, 1,600. Once again, this is the one that wins out. But we could multiply them together. It's A times B times C times D. If we had a score where all of these were 5s, well, 5 to the 5th power is 25, 125, 625. It's over 3,000. If all of these scored on a 5, you would still have a better solution than really these three. It doesn't score 10 in any of the categories. A score of 7 in all of these, it definitely wins out. It all depends on your weight. Whereas if you add a score of 7 in all of these, 7 times 5, you get a score of 35. It's only as good as this. So really how you build your scale, how you build your score, is really strongly dependent on what you find to be the best mathematical evaluator. Which again, depends on how you picked your values. So that's a bit about decision matrices. On Thursday, we're going to be discussing some introduction to SolidWorks. Hopefully we'll get that live streamed. In fact, I should be able to get that live streamed because I can just do that through sharing my screen here with my laptop. Thank you for watching the video all the way to the end. I know this is kind of lengthy, and thank you for your patience in all of this.